Alright, let's move on to question number 4. So it says that let F be the set of families that have 2 children. So if the probability of being a boy is equal to the probability of being a girl, then obviously this is also going to be a fraction of 1/2. So they add up to 1. There we go, 1/2. And what comes afterwards? Well, there's again an equal chance of it being a boy or a girl. Boy or girl. This of course shows us that they are independent events. It doesn't matter what the gender of the previous child is, there's still a 50-50 chance of the next one being either gender. Okay, so we've completed the tree diagram, we've done part A. Part B, what is the probability that a randomly chosen family has got 2 boys? So 2 boys, this is the outcome with 2 boys. 1/2 times 1/2 equals 1/4. So there's the probability for part I, 1/4. Part double I, 2 boys, if it is known that the first child is a boy. Okay, so we know that the first child is a boy. So because we know that the first child is a boy, we've effectively told the reader that we are here now. We've given you that this event right here has occurred. What is the probability then of having 2 boys, that is to say a second boy? Clearly it is 1/2. So when you've been given a prior event, in this case what the first child's gender was, we can walk along that path because we know that this has occurred, and we'll just measure any ensuing path's probabilities. And lastly, 2 boys, if it is known that there is a boy in the family. Wow, alright, I'm better write this one down. So this is the probability of getting boy-boy given that we have either a boy-girl or a girl-boy. Or, I suppose, boy-boy, right? I suppose there are 3 ways that we could have at least a boy in the family. Oh, wow. Alright, so this is going to end up being, then, the probability of both of these things happening, boy-boy and either boy-girl or girl-boy or boy-boy, all divided by this given probability of being at least 1 boy in the family. So boy-girl or girl-boy or boy-boy. So always when you are dealing with a conditional probability, and we can't just read the answer off of the diagram because you've been given the very first selection that was being made. So then in that case, use the formula, the conditional probability formula, which is the probability of both events happening divided by the probability of only the given event. Alright, here we go. What's the probability of having boy-boy and at the same time you have either boy-girl or girl-boy or boy-boy? Well, for both of these things to happen at the same time, we have to be boy-boy. If we're not boy-boy, well then this part of the AND did not get satisfied. It would be like getting a false true in a logic diagram, giving you a false output with an AND, a conjunction. So because we know boy-boy must occur at the same time as this, clearly our situation here is boy-boy. So our numerator then just becomes 2 boys, 1/4. And so we've got 1/4. What are we dividing by? Well, we're looking at boy-girl or girl-boy or boy-boy. So we better add those 3 possibilities together. Here's the boy-boy, here's the boy-girl, and here's the girl-boy. So let's add up those 3 probabilities, which is 1/4 plus 1/4 plus 1/4. Turns out that all 3 of these probabilities are 1/4, giving you a total of 3/4 on the bottom. And the 4's will cancel out, leaving you with a final probability of 1/3 for part triple I. Okay, so the probability of both of them happening divided by the probability of only the given event. Alright, let's move on to number 5. So we got 2 jars that contain a number of colored balls. We got jar 1 with those 5 and jar 2 with these 3, and we got black and white balls in each one. Alright, the first experiment, a jar is first chosen and then a ball is drawn from that jar. We need to create a tree diagram. So first we're choosing the jar, jar 1 or jar 2. And then we're choosing a ball. It's going to be black or white, black or white. Let's fill in the probabilities. Because the jar is first chosen at random, that means that there's an equal probability, like you're flipping a coin. So 1/2, 1/2. An equal probability of each jar being chosen. Now let's look at the probability of getting a black from jar 1. That's 2 black balls out of 5, and 3 white balls out of 5. Or in jar 2, we've got 2 black balls out of 3 and 1 white ball out of 3. They always add up to 1, these probabilities. So we've done part A. We've drawn and labeled the tree diagram to show all possible outcomes. What is the probability that a white ball is drawn? Well, there's 2 ways a white ball could be drawn, right here and right here. So let's calculate those 2 different probabilities and then add them together. 1/2 times 3/5 will be this first one, 1/2 times 3/5 as I multiply the probabilities along its path. And this one is 1/2 times 1/3. So this one gives me 3/10. This one gives me 1/6. I need to add these 2 things together. I'm going to do this by finding a common denominator. Of course, you can use your calculator and get decimals if you want, and then convert it back to a fraction. I'm just going to do it with fractions the whole way, with a common denominator of 60. So I multiplied the bottom by 6, let's multiply the top by 6. Common denominator is 60, I multiplied the bottom by 10, so multiply the top by 10. And now add them together. 18 over 60 plus 10 over 60 gives us 28 over 60. And that reduces to 7/15. Alright, second experiment. The ball drawn in the first experiment is not replaced. A second ball is then drawn from the same jar. What is the probability that both balls are white? Okay. Well, we better redraw a tree diagram now. We've got either jar 1 or jar 2. And then we've got black or white for the first selection, black or white for the second selection. Now, I've got black or white coming out of here, but I'm not going to be interested in those possibilities because I want both balls to be white. So I'm not going to complete that part of the tree. The white could end up with a second white. That one interests me. Alright, let's suppose I came into jar 2 and I got a black or a white. Well, if I got a black, it doesn't matter what transpires after that because there's no way that I'll get 2 white balls, which is what I'm really looking for here. But if I drew a white first time, then there is a chance that I could get a white on the second draw as well and ending up with 2 white balls. So again, I'm only interested in 2 possibilities, this one right here and this one right here. Although there are 8 outcomes, only 2 of those 8 outcomes involve 2 white balls. Jar 1, white, white, and jar 2, white, white. So, let's figure out those probabilities. We chose a jar 1 by random, so that was a 1/2 probability. And then we said that there were, how many whites in jar 1? There are 3 whites, so that's times 3/5. And then we're not replacing, so now there's only 2 whites left out of the 4 remaining balls. The 2's will cancel, and that will give us 3 over 20. Let's now work out the second possibility to add on to it. So we've got a 1/2 chance of choosing jar 2 because it was chosen at random. And then inside jar 2, we've got 1 white out of 3 balls. And then once we've taken it out, there's only 0 whites left out of 2 balls. In fact, it's impossible for me to get 2 whites out of jar 2 because jar 2 has only got 1 white ball in it to start. So this whole probability here becomes 0 because we're multiplying by 0. It cannot occur. And so when we add these 2 numbers together, we end up with simply 3 over 20. Number 6. The probability James gets up before 7 o'clock is 0.95. There it is. Clearly then, this amount down here is going to be 0.05, 5%. If James gets up before 7 o'clock, so here we are, we're right here now, the probability that he arrives at school on time is 0.98, so that must be 0.02. If James gets up later than 7 o'clock, so now he's down here, then the probability he arrives at school on time is 0.55. So that's like 0.45. Okay, so we've completed the tree diagram, we've done part A. In part B, let's calculate the probability that James gets up before 7 o'clock and is on time for school. So, he gets up before 7 o'clock, that's here, and he's on time for school. That's right here. So this path, he's on time to wake up and on time for school, is 0.95. times 0.98 as we multiply that path, and I need to do this one on the calculator. 0.95 times 0.98. Uh-oh. Looks like my calculator has failed. Well, I don't know if I can reboot this on the spot. So I'll try to finish this example without a calculator. Please do your best under the circumstances. The answer to part B then is 0.95 times 0.98, whatever that gives you, okay? And lastly, part C, calculate the probability that James does not arrive at school on time. There are two ways in which he does not arrive on time. That's right here, not on time, and right here, not on time. So we need to add those two possibilities together. This first one is found by doing 0.95 times 0.02. And the second one is found by doing 0.05 times 0.45. Alright, so we're going to find these two amounts, and then we have to add them together, and whatever you get, sorry I can't do it with the calculator right now, whatever you get ends up being your answer to number 6. And we'll do numbers 7 through 10 on the next video.